Thanks a lot for the introduction and for inviting me to come, and thanks everybody for showing up. In Denmark, seminars at 5 would not be attended, so I'm pretty impressed that you actually have all come. So what I wanted to do today was to talk a bit about my work on body-based user interfaces and try to make sort of a status over what I've done in the past 3 or 4 years on trying to make the body a sort of primary side of human-computer interaction. So let's just begin by thinking, maybe each of you think about interface you actually enjoy using, and just think about the senses that you engage in interaction with those interfaces, and on the parts of your which parts of your body you use. And whenever I think about it, it's fairly clear that we use hands and we use vision, and that's about it. So sometimes this is made into this joke drawing of how user interface designers supposedly see humans, mainly as touch and vision, and perhaps as ears. And it's actually been sort of that model has been true since mainframes. It's true for most mobile devices, and it's true even for emerging technologies like VR. In contrast, I've been interested in thinking about what other aspects of the body we might use in human-computer interaction and as an interface. So just to give you some examples to start out with, well, it's fairly clear that we can use movement as input. I mean, I never understood why doesn't PowerPoint adapt the font size, say, based on my distance to the display, because here I'm fully unable to read my notes, so why couldn't we do something like that? It's also clear that besides touch, there's a lot of other things we could tap in. Interfaces, gestures, or poses are commonly not part of normal communications with computers. They could be. Maybe it's a bit geeky, but if you think about it, we're probably around 2 square meters of skin. That's a wonderful place for input. It's a wonderful place for output in form of projection, and it's very rarely used. Of course, we can do all kinds of sensing on the body, sensing muscle movements, sensing physiological reactions, and so on, and try to integrate them and make them a part of user interfaces. Increasingly, we'll have non-medical devices implanted that, of course, is also will be a sort of part of our interaction with computers. And finally, there's all kind of mechanisms of our body when it tries to tell us things that are actually pretty exciting for use in human-computer interaction, like itching and goosebumps and so on. I'll show you at least one example of that, but potentially that could be part of interaction as well. So the way I think about all of these things is, I call them body-based user interfaces. It's mainly to distinguish them from sort of the old, boring interfaces that mainly use vision and haptics, but it's sort of a rather loose definition. But it's just to give you a sense of what my focus today is. And if we think about those interfaces, it's fairly clear commercially and academically that there's plenty of them that are emerging. So just to give you a couple of examples, in this interface, you can actually move in front of a large display, and you use the direction of your movement to zoom in on a map. There's plenty of interfaces where you use gestures. In this case, you use gestures at a distance from a display to give text input. And there's also quite a bunch of work that tries to take, for instance, the display surface of a smartwatch and extend the interactable area onto the arm, so you can actually, in this case, sort of drag Angry Birds on your arm, so you suddenly have a large area of interaction. There's plenty of other examples. So what's interesting about these types of interfaces, besides sort of tapping other modalities than our sense of touch and our vision, is that at least potentially it could be that we could actually interact without holding on to a device or without having to look at a device. So I think one of the nicest early examples of this is Sean Gustafson's work. So it's called Imaginary Phone. So he basically did a system where you can hold up your hand like that, and then you can gesture in this space, which is then mapped to the home screen of your iPhone. I guess it works for other phones as well. But the point is that we actually have quite good memory for the location of icons. So he showed that you could do gestures like that, and well, I would do this and that, and I know it's calling. So maybe we can get rid of at least some of the devices we carry around, like for instance also this one, or phones. It's also clear that at least potentially body-based user interfaces can be more expressive. So there's some work that's trying to do skin gestures. So you can actually do quite nice interaction on your skin, which is not possible on rigid screen surfaces. And of course, I can do way more exciting things with my hands in the air compared to when I put it on a touchpad. So that's another sort of potential. And finally, there's the hope that maybe these interfaces could actually change the experience of the interaction, so they are unmediated in a way. There's no device. There's just me using my body. And as I will show, there's also the hope that because we have a very special relation to our bodies, maybe just that fact can actually change how we think and experience interaction. Unfortunately, or not unfortunately, I guess, because that's funded my research for the past 4 years, but there are a couple of quite big problems in relation to these interfaces. So the first of those is that, those of you who have taken HDI or similar course will know that we have an endless amount of guidelines, for instance, for how to design menus, right? It's not super clear, though, if you want to do menu interaction, say, on your forearm. How do you use those guidelines on people's forearms, or even, or does those guidelines at all apply to on-skin interaction? It's a bit similar. So when we have tablet and we interact on the tablet, it's sort of brain dead to relate you relate the position of the finger to that's placed on the screen where the finger is at, and that's your input point. That's rather simple. But then if you don't have a tablet anymore and want to do media interaction, it's pretty clear that, well, okay, you can curve the surface, you can use depth, you can scale it, or you can scale it dynamically. So there's many mappings possible. That's just not possible here. And currently we have no idea really how to do that. So the other main problem is that I just listed several attractions of body-based user interfaces. But the other problem is that when we actually have comparisons between normal interaction, say touch-based interaction, and say something that taps the body, say mid-air interaction, this is actually not true. This is what we would like, but usually normal interfaces win. So we've done some studies that compare mid-air interaction with on-tablet interaction, and you're just 50% slower when you interact in mid-air for a variety of reasons that are actually quite interesting. But anyway, we don't have many examples of when body-based interfaces perform better, and we don't have many good explanations for when they actually perform better. So my research currently and for the past couple of years has been trying to understand these interfaces and trying to address these two challenges. And in particular, I have been interested in using, I see you are co-located with psychology, so I've been interested in using a particular psychological theory, or rather interdisciplinary research area called embodied cognition, but in part from psychology, in part from linguistics, artificial intelligence, cognitive science, other areas that has explored the relation between how we think and feel and act in our body. And I think one of the main pieces of inspiration is that relationship, or our body and our thinking, is much more intertwined and entangled than you might think. So we're trying to use that to drive innovation in user interfaces. I'll show you today some examples of how we do that, and just to create this is a few of my colleagues that worked with me on this project, but I'll call them out as we go along. So anyway, some examples of how this might actually work out for designing user interfaces. So one of the like canonical examples of how the body and our minds are entangled is the relationship between affect and the body. So I guess for more than 100 years in psychology there's been this idea that of course our bodies reflect our affect, so affect being a psychological term for emotion or feeling, but the other way is also true, so particular states of our body can actually induce or create or construct particular affective responses. So in a couple of example studies, so at one stage, this is controversial, I'll get back to that. At one stage, you believe that if you just stood like this for 30 seconds, you could boost your testosterone level, you can increase your risk willingness, and a number of other, your confidence, and a number of other traits. So this was the whole power pose idea. So that's one example of thinking about the relation between affect and body. Another example that I really like is an old psychology study where they showed that if you look at stimuli, say images, while you push away from yourself, you tend to dislike those stimuli more than if you pull towards yourself when you look at the stimuli. So that's approach avoidance motivation, of course, like it's stuff we push things away we don't like, or we eat things we do like. So a similar mechanism is believed to, or shown in this study, to hold for movements. And we've been interested in, okay, these are nice basic ideas about the relationship between affect and body, but we've been interested in if we could use those in user interface design. So the first attempt we tried to do at pursuing this idea was just see if we could somehow use it for phones somehow. And basically the idea, so the idea there was that there's other psychological research that indicate that your movement is affected by how you feel, so that you move slower and more precise, sort of in general, when you're in a positive mood compared to when you're in a negative mood. And there's all kind of crazy evolutionary explanations or attempts at explanation for that, but okay, let's just keep that in mind. So we are interested in looking at whether we could actually, from how people moved when they interacted with their phones, predict how they feel. And so the way we investigate this is we do mood induction, which is a classic procedure where you make people watch movies that are supposedly neutral / boring and fun. And after people have watched that, you can do a manipulation check and actually see that indeed the resulting affective state have been obtained. And then what we do after that is that we have people interact with their phones, the most boring Fitzlaw type task that you can think of. And then we take as many features as we can actually get from a phone just during the actual movement components of this. So that's stuff like speed, acceleration, how much you tilt or shake your phone while you do that. And then our attempt at linking the body to affect is we want to go from those features to predicting which movie people saw. And that sort of works in that we find a number of features that can go into a rather straightforward classifier. They are some of the features you would expect given what I said earlier about movement and precision when you have positive effect. And we can, for instance, if we ask, so this one, let's take this one, in part because it's the highest. If we ask people to self-assess their mood after doing the tasks I show you, we can predict with 89% accuracy which mood they self-assessed as. We can also do it on a Likert scale from positive to negative and sort of be within one scale point of their actual mood. So none of this is perfect, but some of it is good enough to actually use the mere fact how you move to make predictions about how you feel, and therefore, say, adapt interfaces or whatever you want to do with this information. Actually, we sort of continued with this. So this is a study I won't tell, but it's in the same space of trying to infer complex cognitive states from movement. So we actually show this spring that just by looking at how people move on their phones, we can predict slightly worse than the accuracies I just showed whether they lie or not, which is also kind of fun. Another thing we tried in this space is to see if this link from body to how we think and feel, if we could use that for gestures. So the idea in this study is that the power pose stuff I showed you earlier, you're actually supposed to stand like this for it to work, or that. But then we thought that there are actually interaction styles where you interact in a particular way. So we call those, we call that sort of incidental postures. So for instance, if you use large displays, or actually what I'm doing now, I guess I'm more expansive than when I'm typing at my computer, right? And so in these situations, you would actually have sort of a power-like pose, and in these you would be more constricted. So the theory here is that maybe we can design interactions that actually affect people in the same way as some of the studies I showed you before. So in one study it was very simple. We just had people tap like this and like this, and then we asked them questions about some of the states that earlier work have claimed would result from these poses. The one I'm going to just focus on here is whether you feel powerful or not, or on a 1 to, or I feel powerful, agree, disagree, on a 1 to 7 scale. And in this particular case, you can see the means for powerfulness there. So this is the expansive pose or the B pose. This one shows the constrictive pose or the A pose. So in this particular case, even though there's a difference in the direction we expected for 40 people, it's actually not significant. It might not be clear from these pictures, but of course in this setting it's actually extremely fatiguing. It's not going on for that long, but standing like this, tapping as fast as you can is sort of less fun than doing it like this. So we thought maybe here discomfort could be an issue. And the other concern was that maybe it's just too dumb to ask people if they feel powerful or not. So maybe we could have an actual behavioral measure for whether they are more powerful or some of the associated feelings. In this case, we took whether they're willing to take risks. And there's a kind of weird instrument for measuring that, which is you get to pump up balloons and you get money, you get monetary reward corresponding to how much you pump them up, but occasionally they explode. And if you do that in complex ways, you can see how much sort of people push the limit to make more money, and that's then a measure of risk willingness. So anyway, we had people sit, or maybe this is easier, sit like this and do this task, and then we hope that would work out better. Unfortunately, that's not working at all. So there's quite a number of intricate ways you can analyze this, but the bottom line is that there's actually no difference in risk willingness between these poses. And this paper from Kai this year is by I did it with Yvonne Jensen. It's sort of a one long Bayesian statistics attempt to figure out if anything could be hidden in this, and there's actually not much. So this means that in the effect case, this link seemed to work quite well. In this incidental power pose setup, it just doesn't transfer from the incidental poses into the effects we would like. And and at least we think that sort of pursuing this more in HCI is not particularly fruitful. Right. So that's a little bit about this link between movement and thinking. So another thing we've been interested in is more along the movement. And it basically it's still it's based on the fact that there's quite a lot of things that we only know through movement. Feeling texture, for instance, is one very nice example. So you actually don't feel texture. I don't feel texture if I do like this. I only feel texture if I move my hands. And so we've been interested in trying to understand that phenomenon. In particular, we've been interested in trying to understand if we can create texture synthetically. And that's and the vision of the idea here is that if we can couple movement of people to texture production or to actuation or vibration or some other stimuli of those sensors in your hand that actually feel texture when you move, maybe we can create it in, for instance, midair. So this is work by Paul Strohmeyer. So we built, I mean, it will get sensible in a bit, but we have to go over this weird gliding thing. So we built this gliding rod. So there's a haptuator, which is essentially a tactile unit that works a little bit like a microphone, so we can, a loudspeaker, so we can stimulate it in the same way. It doesn't make sounds, but it makes vibrations. And then there's an optical sensor on this thing that can register how fast or how much you move. And so what goes on is that we can make the haptuator produce different tactile stimulations when people move, and then hopefully they'll get to feel different textures as they move. And specifically, so there's a lot of details about, so this is sort of classic psychophysics. I don't want to go into this, but because this works as a loudspeaker, we can do some of the same things, like we can vary frequency, we can vary amplitude, and we can vary what corresponds to timbre if it was sound, sort of the profile of the actuation of this. And then we can ask people about different aspects of texture, like roughness, sharpness, adhesion, bumpiness, like that's basic texture qualities, and we can try to establish a mapping between those. And so what that comes to is a lot of graphs like this, and the basic idea is that we can relate variations in granularity or amplitude or timbre to perceived qualities of texture like roughness and sharpness. And what's important here is that some of these actually affect, the perception of sharpness or timbre. Well, timbre also, but in a more complex relation affects sharpness. And so when we know that, we can do the next thing, which is actually the interesting thing. So. Well, it's quite difficult to illustrate. That's fine. It's quite difficult to illustrate vibration. So here I play the sound that you should imagine is not a sound but a vibration. Okay. And because it's a microphone, it's actually it's because the tactuator I showed before is actually a loudspeaker. It's actually this exact sound that produces the tactile sensation. But then in this setup where we can track people's movement, we can then create all kinds of textures. Potentially we can get rid of the thing that's just for tracking. We can produce textures in midair. So for instance, that could look like this. So you can move your hand around, but then when you return it, you can suddenly feel the texture of something in midair. So that would correspond to actually having dials. So only when you begin dialing on them, you can feel them. Otherwise, they're not there. You can also have other mappings where there's something like a texture gradient in midair that you can use to guide people to a particular place. But all of this is, well, it's sort of very basic about the link between action and perception, but more importantly, it's a stepping stone towards being able to do textures and objects and haptics in virtual reality, which is sort of one thing a lot of people would like to be able to do. Right, so next, I just wanted to talk a little bit more about, maybe I'll skip one of the studies, a little bit more about skin input, because at least for HCI researchers, that's one of the more exciting areas of body-based interaction. There's these 2 square meters that just beg to be used. And currently, so these 3 are papers about how you sense on the skin, and currently we can do that quite well. So you can do you can put microphones on your arm, and then you can actually locate the finger or touch points on the arm quite well. But as I told you before, I'm a bit more interested in okay, so how do you actually I'm happy for someone else to solve the technical problem, but how do you actually place items on the skin? Is this useful or not? Is it actually something I would want to use compared to pulling my phone out, say? So in this particular study with Joanna Bergström-Letovirta, we were interested in all of those cases where we have external things. Maybe the phone is the best example, and we want to map that onto our skin. How do people do that? What are the useful strategies for doing that? And what are some of the guidelines we could actually come up with to support interaction designers in making those mappings once we get to need to do that? So in this particular study that I just show you some examples of, we had a list of random things that we asked people to map to their forearm. And they were going to map it in a way that they would find locations where they would place all of those 30 items. Then they would be distracted in various ways and had to recall them in different ways. And we wanted to look at how do you actually, like when commands are on your body, how do you do that? And so in that way, it's not about performance. It's not about I don't know. It's mainly about the strategies people use, and it's about the error rates and what can we learn for how people use their arm for remembering commands. So, not surprisingly, like the objects or roles I showed you before are to a large extent put on this large part of the arm, and to a large extent put on the fingers. So that's not super surprising. On the fingers, people use nails, and those are, that's probably not knuckles. It's it's those parts of the fingers. Maybe they're knuckles. I'm not entirely sure. And those middle spots are not used as much as the tips of the hands. That's actually knuckles, and that's used as well. There's other anatomical landmarks like this soft spot. People place objects there. They use the bones. They use this wrinkle here. So all kind of anatomical landmarks that are used to place objects on, and therefore used to aid recalling them later on. There's also a lot of landmarks that are individual scars, tattoos, birthmarks. And sometimes there's even complex semantic relations between those. So maybe you remember from the list, there was a nurse was one of the items that should be recalled. So that was by some participant placed on the scar to sort of form an association. All of that, of course, we're interested in whether they can actually recall stuff, and then whether this is a feasible alternative to, say, having a visual interface or device. And in general, they recall 2/3 of the items, and actually mapping those items to either fingernails or these personal landmarks boost recall a lot. So tattoos are stuff on tattoos are recalled by 100%, and on scars by also way over average recall. So all of this is simply to begin to understand how unique and individual features of the body can actually be used in interfaces, and to establish some first guidelines for where to place stuff, either where to let people place things or where to place things so that we, for instance, know how to design menus. Oh, let me just skip slightly ahead. So the stuff I told you so far has been about sensing, and it's about the input on the skin. And one of the things we've been quite interested in, and which is slightly counterintuitive, is how do you use the body for output? And the most obvious thing, projection, just happened to not interest me because that's well, there are other people that do that. That's quite exciting. But we've been trying to understand if there's other ways of making output with the body that's not projection. So the first attempt at that is work by Jared Knippe and a couple of other people, and we thought about using electric muscle stimulation as a form of output. So the idea in electric muscle stimulation is sort of simple. If you maybe try it for fun or rehabilitation. So if you have two pads and you has a current between them, if you hit a muscle, you might get movement. And so what we're interested in here is that if you get movement, that's essentially output. So we were interested in figuring out if that is feasible and what it can be used for. The only problem here is that you actually have to put those pads on people. It requires anatomical knowledge, because if you don't hit a muscle, nothing happens, or well, can actually hurt, and nothing happens. So this has been quite a big problem in the human-computer interaction for the people who wanted to use this for something. So what Jared has been working on is simply to do what we do best, just brute force the problem. So he had made this sleeve that contains a lot of electrodes, and then changed the problem not to one of placing the electrodes, but just to one of figuring out which electrodes to stimulate to make a particular muscle fire, and therefore to make your hand, say, move in a particular way. Of course, it's not super easy to know which muscle to stimulate, so the other component of this sleeve is to be able to read what your muscles do. So the idea is that if you actually do a movement first, we can read that movement, and we can, it's a hope, redo it by stimulating what we just read from the muscles. So the prototype is called Body I/O, looks like this. So we're not, unfortunately, electrical engineers, so that shows. But anyway, it does what it does. It does enable both muscle stimulation and reading which muscles fire during a particular movement. Okay, there's a video of it. So one example of use is that you do a pose. In this version, you unfortunately have to hold it for forever for us to read all pairs of muscle activity. And then once we've done that, we know which muscle to stimulate, and so we can use a particular EMS pattern to stimulate the hand so that it hopefully moves in a particular way. So that actually turns out to work reasonably well for quite simple poses. So we can do stuff like this and that with decent accuracy. There's still quite a lot of work left to perform this, but of course our idea is that like something like, wouldn't it be very nice if your body could actually be used for output, so you could download okay, piano is a bit far out for our skills, but you could download a particular movement pattern, and you could learn it and have it repeated and gradually sort of transition to do it on your own. So that's the idea here. So, and of course you can use that, say, in gesture-based. You can use that for piano. You can use that in gesture-based interaction, where you first have the computer learn you what the possibilities are, and then later on you learn them and do them on your own. The other example of output I sort of revealed earlier is about the body's natural signals and how we can use them in interaction. So this is work by Henning Pohl, and that sort of departs from the variant of the finger ear person I showed you earlier. Specifically, all notifications that we receive are either vibration or visuals or sound, right? So that's how devices today notify us. And it's actually not particularly interesting or exciting, and it doesn't tap many of the other ways that our bodies works. Because if you actually think about those, then we just have an endless supply of possible notification modalities. So, I mean, goosebumps actually tells us things about feeling cold or being afraid. Yawning teaches us things about the state of our body, as does blushing. So we're interested in can you actually use any of these in human-computer interaction? And the one we specifically picked here is itching, just because that's actually a signal to notify us. The common theory of itching is that it's to notify us about hygiene, that we actually need to remove some things or clean ourselves or remove an insect or other type of irritation. So we wanted to figure out if we can use that in interaction. So what Henning built is a very, very simple prototype of a watch that can itch. And there's a lot of, like in the paper that was mentioned before, presented a month ago at WIST, there's a lot of details about how you actually do electric stimulation to make it itch and not, say, hurt like something that's not an itch. So that's a little complicated. But once we've figured out how to do that, we can make a watch that itch like that. And I guess my own user scenario is actually to have a watch that either remind me when I use social media too much by increasing the itching, which I thought would be cool, or alternatively nudge me to walk whatever number of steps it is I need to take a day. I don't want to look at those counters. I think they're terrible design, but it could actually begin to itch when I should feel like I should walk, which I think would be a nice form of notification. Anyway, so there's actually an electrical itch stimulator that you can download that Henning built, which do these very low current EMS in a way that makes it itch. And as I said, well, it's very simple. It's copper that's wrapped around a smartwatch. And the main benefit, besides we think it's fun, is that it actually uses way less power than vibrotactile feedback. So if nothing else, there's a nerdy energy-saving argument. So as I said, we did a couple of studies, but one of them was just to compare it to vibration, just to see what people actually think of itching versus vibration. And it's quite interesting to see. So we asked them about activation and about how interrupting these notifications delivered by either vibration or itching was. And it's quite interesting to see that itching is actually sort of more activating and more interrupting. So maybe that's something that can be used, or there's a reason or an occasion to use itching over vibration. We also asked about a number of specific scenarios, like for instance, do you want to goal was scored against your favorite team? Do you want to receive the notification as itching or vibration, and a number of similar questions. And the main thing is that there is actually variation, and that itching seems to be preferred in more serious scenarios. Okay, so that was just examples of projects, I guess, sort of all over the place that I've been doing for the past years. So let me just sum up by returning to those questions I talked about in the beginning. So the first of which was the lack about models and theories and guidelines on how to do body-based interaction. And I think there's increasing number of such models. So we have done some for on-skin input. There's some also done by us on mid-air interaction. As for the theories, I mean, I as you could see, for instance, for the Post study, I'm quite interested in body cognition, and at least for me, that offers way more predictive power and interesting design direction compared to embodied interaction, which is sort of in vogue in human-computer interaction, but I don't think it helps us design very much. The other question was about performance. I think it's still the case that there are actually very, very few well-performing body-based user interfaces. So I think my favorite example is that we have, I don't know how many people doing computer vision or other modeling of how people's hands move so that we can track them. And at least in HCI, what do we use that for? Well, we show images of people's moving hands on displays. But if Orca just enlighten me if I'm wrong, but actual mid-air interfaces that use the full degrees of freedom of the hand to do something interesting is very, very rare, if not non-existing. And I think that's a bit sad. Of course, one way of thinking about this is that, well, it's not about performance, it's about other modalities, and that's why I showed you the itching case, because I think that's definitely not better performing, but it might be a modality that's actually very well suited for something. Another way, of course, of just summing this up is just to think about if you relate, I don't know, this to that, right? So what is the essential difference that should matter for people who do HCI or user interfaces? And I guess this is my working list of at least four key differences. Body and thinking are intimately linked. You saw that in the effect case, right? That actually those things play together in a way that we can use in human-computer interaction. The other one is, I guess, mainly, or the second one is mainly the itching example, but also the muscle stimulation thing. We have muscles, we use them all the time, and we can actually computationally control them and try to use that for something interesting in interaction. I really like the fact that when people have to recall stuff on their bodies, it's all the individual differences in morphology and so on that matter to recall performance. So I think just making body-based user interfaces that really use those individual differences for something rather than doing some one-size-fits-all is crucial to getting those interfaces to work well. And finally, I think this is just super important that a lot of the time our perception is linked to action, right? So we perceive, but we perceive what's in our back pocket by moving our hands around. And I think what I try to show with the texture and mid-air study is that actually using movements like that, exploratory movements, for something in interaction can be extremely powerful. But thanks a lot for your attention this late, and I'm happy to take some questions. Well, I'm happy to take questions. I don't know if that's the schedule.
Yeah. So, questions from the audience? Otherwise, I have some warm-up questions for you.
Good.
You show us several examples about body-based user interface, but when it comes to location that people need to remember, for example, the placement of the keywords, and also many other examples, like at the beginning about body-based user interface. It seems that users still rely on visual modalities to recall the location, imaginary phone, for example, and like use visual cue, for example, the landmark of their body in order to associate with that. Do you see in the future that there could be some user interface, especially for input or for recognition from human, that can leverage the fact that we just have proprioception without having to rely on our visual perception?
Yeah, no, sure. That's a really good question, and that's definitely true. That at least the examples I showed here are at least mixed together with vision. So we didn't think of it, but it's actually quite a nice idea to not have vision, right? So you can do similar things without vision. There's some work that tries to do that, for instance, by distributing targets over your body where you cannot look. I think those are much more, I don't know, it easily becomes much more coarse than, for instance, what we studied on the forum. But it's a very nice idea to just look at, somehow I3 recall or some similar setup. And I don't actually know if you just have. I actually don't. I don't know what the capacity is or what the difficulties would be there. So that's a very good question.
Along those same lines, thank you very much. Very haptic talk, engaging talk. Along the same lines that Chad mentioned, I would even take the devil's advocate position and say maybe it's not even vision that helped the task here, but it's location, and I'm a geographer and like location wins, all the time. So the metaphor here was, where are things? Mm-hmm. It's on the body, okay, fine, it could be on the table, it could be on the desktop. So I was wondering if here the body serves just as yet another surface in those examples, rather than, I feel stressed and therefore I want to have a different kind of like haptic to actually manipulate my tool interface. So these examples, I could make this argument, it's kind of mixing some other thing, either vision or location or
yep.
any other metaphor that we know from the last 20 or 30 years of
yep.
user interface design metaphors. And that then relates to what then is the metaphor for the zoom? Is it moving my body forward, or is it my doing something else? So I think that's the question. How do I map those metaphors to the bodily, functions?
Yeah, those are really good questions as well. I think we have, and a number of other people working on skin input specifically have really stuck with this location thing. So either mapping this to that display, or transferring there, or placing objects. I do think in that particular study I showed there was a number of other mappings that were less about, begin to be a bit more about semantics and less about location, but predominantly it was about location. I gave you this example as an example of a semantic mapping. Besides that, I think, I agree. With respect to other, what are natural commands for bodies, or how do we discover other ways of interacting just with our body? I think that's an open and very interesting question. So my example with the hand interaction was not just to tease any vision researchers in the room, but simply just if we could explore, say, whatever GIS data by actually like how I don't know, but it's a question I'm pondering. So how would I, if I have a 10-dimensional data set, how do I map that to a movement of my hand that allows me to do something similar to what I do when I speak, and that's fast, and where you can end up actually maybe feeling that this should be a little more that way, which then corresponds to some weird mix of changing dimensions in the data set. And I don't know how to do that, and actually only know of one relatively old paper that tried to do that. Otherwise, because then otherwise it's I mean, many of the bodily gestures are sort of either obvious, like leaning forward, or they are based on some mapping to clipboard or whatever. It's just not super exciting. So I think the other stuff is exciting, but I just don't know how to do it, and I don't know if many people would attempt to do it, unfortunately.
You mentioned that there is not a clear use case where you can say that these methods are more efficient than with the fingers and the eyes and the ears and so on. Did these studies account for familiarity with the input method? Because when I have my first phone, I was worse, less effective than now with my finger.
Yeah. On the whole, and sort of in rough terms, we didn't. So of course it's always a balance. On the one hand, we have lack of experience against us, and on the other hand, we have novelty for us. And of course those don't necessarily balance each other out, but we know next to nothing about, say, longer term use of mappings of items to the body. At least I'm not aware of studies of that, unfortunately. But it's a good idea.
Do you have privacy concerns about developing this technology? So what I notice in many of your examples is it requires way more information about me and my habits and maybe my mental state or whatever to do a command than my keyboard. My keyboard doesn't need to know how I feel in order to work correctly. And I think this technology can also be exploited very easily. I mean, you could show me ads on my cell phone depending on my mental state. And this, does this somehow, how do you address this?
I think that's also a super good question, and it's a little difficult, in particular when you work with affect, or when you work with something like muscle stimulation, to ignore that, because like whenever I talk about this, I always get the question about what happens if your hand gets hacked, and that's sort of not a pleasant talk, and I fully agree. Likewise, we had a discussion also around lie detection, which we were able to do quite well. What's the implication of that in terms of ethics, and what should be our responsibility in designing those? I think myself, I actually try to stay away from cases where I think that there'll be a lot of ethic considerations, but when we do touch upon them anyway, I think it's my responsibility to think through some of the negative consequences, and possibly also just highlight those in papers and elsewhere. I do think that there's also, for instance, for the lying or affect detection, so if those are not used in a way that's beneficial to you, I'm sure that, and I might even develop that for you, that you can get a plugin that can fake a mood, right? Mm-hmm. Or alternatively, of course, once if it's known that we can now detect lying from how you input on your cell phone, that's then the idea is sort of out there, and it will not be very effective, because then you can likely fake it. So there's a lot of concerns about this. We try to just highlight them in papers, but I also think there's with some of these things there's a possibility for a counterculture, at least, that will actually prevent it from being used in a lot of cases.
How do you think about giving feedback when I interact with a traditional interface device, like a keyboard? I press a key, I see the respective number or letter appearing on the screen. If I move my fingers on my smartphone, I see the picture zooming in or out. How do you think about handling this? I think it should be beyond just displaying something on the screen.
Yeah, sure. So one of the reasons why we're interested in one of the reasons I talked about this texture stuff is that that's actually one possibility of giving feedback in gesture interaction, because you could imagine you actually feel as if there's something there which you just currently don't, and which is one of the reasons why it's so much slower to interact at a distance compared to on an actual surface. We are also interested in doing that on the skin, so you not only can interact on your skin, but actually have haptic feedback as well on your skin. So those are two directions. I guess in one way this whole feedback business is also to some, it's useful a lot of times, but then there's a lot of people that, like a bit like your question, that believe, for instance, in actual proprioception will in itself be a very valuable type of feedback, because if like you would actually know because of the position of your limbs, for instance, what you are doing. So that's, I guess, another type of response. But otherwise, I'm just personally most excited about this coupling feedback to movement, so they can create, say, textures or feedback in media.
Yeah, I was wondering, with respect to the embodied cognition, there's two hypotheses that are often put forward for body-based interfaces, but that often conflict with each other. And I was wondering which you would support. So there's one that the body, interacting with the body always helps stuff. So like in the skin interface, just because it is your skin that it helps, kind of like Sarah's question. And then the other is that metaphors for familiar actions help you interact with stuff. And you can imagine, like with the example, mapping 10 dimensions of data to your hand or something is using the hand. So if it works, you support the first hypothesis, but then it's in such a way that's totally unfamiliar and that may actually hurt performance.
Yeah. Yeah, that's a good question. I don't, like, I'm not interested or smart enough to do basic psychological research, so I don't actually know which of them sort of in the principle is correct. I guess I can see interfaces that tap or use both of them. So I think it's very clear for me when you actually try on-skin input that the fact you not only feel stuff here but also here makes a huge difference in performance. I guess there's an example of natural interactions that we can appropriate and reuse. In some cases, that's useful, but I guess it's rare to see super expressive interfaces that sort of are natural or built on naturally occurring, say, gestures. So I don't. Another point with the hand example is that I think that's a learned thing that you learn anew. You're of course based on what you have experience with using your hand, and you sort of. But I think actually for that to be effective, you would have to learn it anew, and not base it on some pre-known thing. So I guess I'm actually not super much of a natural interaction person, because I think that you get easy benefits from, say, building on metaphors that we know, or building on known skills, but it feels like you very quickly reach a performance ceiling or an expressivity ceiling. So I would, but I have no clue actually, but that's my gut reaction.
All right, I guess that if there are more questions, Kasper will still be with us. We have small apero outside, so we will be able to interact more with Kasper. And thank you, Kasper, very much for your talk and for coming. And thank you, everyone, for visiting.